Okay, Assalamualaikum warahmatullahi wabarakatuh. So today we will continue our class with our next chapter, which is chapter 2 concerning wind energy. Okay. First of all, I'm very sorry that I couldn't do this course, this lecture live online with you, as I have a bit of family matters. So, but I hope that you watch this video, this recorded video, and try to understand. And you can ask me by WhatsApp or email to me anything that you want to ask or you don't understand. I'm always available, inshallah. Okay, so our first chapter last week it was about introduction, more on the introduction. We recap back the fundamental of thermodynamics. I hope that you did some revisions on your fundamentals of thermodynamics, and then I introduced to you the some of the data statistics on the current situation of renewable energy technologies worldwide and also in Malaysia, right? Okay, so after this, this coming few chapters, chapter 2, chapter 3, 4 and 5 and so on, we will discuss, we will look at one by one example of renewable energy technologies that are available. Okay, so we will start with the first one in chapter 2, which is about wind energy. Okay, so let's start. Introduction. So I think all of you have know, at least you know what is wind energy, wind power, right? So this device basically, this type of technology use turbines. Okay, so somehow, I talk a lot about aerospace application because our department is aerospace engineering department. So basically what we do in wind energy application, the fundamental, the basic knowledge in wind energy is that it applies turbines, the turbine concept. Okay, so this turbine concept for aerospace engineering especially, or mechanical engineering even, we study a lot. We at least we know the fundamental process in turbine, right? You know that. So this technology of wind energy, it use and it applies the concept of a turbine. Okay, so I hope that this is not something new for you, because you already know what is turbine, how turbine works, right? From mechanical and aerospace background. So so the same as in wind energy, since it use turbines, so basically the concept, the how to calculate to evaluate the performance of wind energy, we apply a lot of the knowledge on turbine, the fluid mechanic behind the turbine. So we are going to see that. Okay, and then okay, so what does wind energy do, and how does it works? So basically, this wind energy, it use turbines and it extract energy from the fluid. Okay, fluid here is the wind. The wind is the fluid, the air, the oxygen, the air around. Okay, is the fluid, the main fluid. I mean the source of energy for wind energy, for wind turbine. Okay, so wind turbine, the device, it extract the energy from the fluid and convert it to power, electricity, mechanical power. Okay, so like I've mentioned last week, the fundamental part is that, if you remember well, the energy, the first law of thermodynamics, it mentioned that energy cannot be created nor destroyed, right? Energy cannot be created nor destroyed. That is the first law of thermodynamics. So, but energy can be transformed from one form to another form, right? So this is what wind energy or wind turbine applies. So it applied that concept. So that's why it is important to recall again, to refresh back this the thermodynamic concept. Okay, because we apply the thermodynamic concept, which is the first law of thermodynamics, when we for this wind energy technology. Okay, the concept is the same. Okay, so and wind energy, wind power, wind turbine, it extract the energy from the fluid. So the fluid has energy. Okay, the movement of the wind, the fluid here is the wind speed, right? It has a kinetic energy, the flow of the wind. So it extract the turbine from the wind turbine. It extract the energy from the fluid, and it transform to another part of energy. Okay, so I write it down here. So this is the first law of thermodynamics last week that we saw. Thermo, okay. Energy from one form, transform to another form, okay. To another form of energy, for example, mechanical energy, electrical energy, okay. Starting from the kinetic, the speed of the wind, okay. So the speed of the wind, it has kinetic energy. So this kinetic energy comes from wind speed, okay. And there are also temperature, depends on the temperature of the wind, okay. Wind speed. So the okay, fluid here reflects the wind. Okay, the wind air. Okay, surrounding. Okay, so we have a windmill. An example, we have windmill. So this windmill it's used for mechanical power generation to pump water, right? Okay, and then wind turbine. Okay, wind turbine, the principal one that we use, it is used for electrical power generation. Okay, so here the world's total wind energy capacity increased to 539 gigawatt. Okay, gigawatt is 10 power of 9, if I'm not mistaken, as of 2017. Okay, so the total wind energy capacity have increased to about 500. Okay, more than 500 gigawatt. So basically, the world leader is still China, US. Those are the main producer, okay, of wind energy. And Europe, Germany, France also, actually Spain, okay, because they have the wind speed over there, especially at the northern area, northern hemisphere, okay. Europe, US is those are countries from the northern hemisphere. They have a very strong wind, so that's why they can apply this wind energy. Like I've mentioned last week, Malaysia, basically, maybe we are these technology are not really expanded, I'm going to say, okay, because one of the reason is that we don't have that or the source, which is the wind speed as high, okay, as big as significant as the those country, okay. Okay, so the world's total wind energy capacity can cover more than 5% of the global electricity demand in those countries, and it increase in wind power. Okay, the wind power have increased between those recent years from 16.6% to 10.8% respectively. Okay. Cost of wind power has dropped from 50 cent per kilowatt hour in early 1980s to 0.082%. Okay, so it the the cost, the cost of of electricity, wind, solar, etc., when the cost is dropped, means that the the energy is being more used, being more used by consumers worldwide. Okay, when the energy there is more, is being used more. Okay, so normally the price will drop. The same as in for solar PV also. Okay, solar PV, more and more. Okay, until recent years, the price drop more and more because there's a lot more company industry that can produce the solar PV. Okay, so the price drop means that it is more being used. Okay, next. Okay, so wind is a form of solar energy. So actually, this wind energy, it is somehow a form of solar energy. So it's a bit how do you say? It's a bit janggal. When we say that wind is one form of solar energy. It is one form itself. It is one form of another technology. Okay, caused by a combination of three concurrent events. Okay, so it starts from the sun unevenly hitting the atmosphere. Okay, the sun hitting the solar, it hits our atmosphere, our ambient, and then irregularities of the earth surface. Okay, the surface of the earth, there are different level, different altitude. Okay, we have mountain, etc. So the irregularities of the earth surface and the rotation of the earth. So our earth rotates. Okay, so we know that. So these three events cause cause the wind cause the wind. Okay, wind in our ambience. Okay, so from there we have wind. Okay, so and then areas with a wind speed of 6 meter per second or higher are potential sites. So okay, so in order to have to know that if we can apply or not wind energy technology, one of the factors is that we should have, it's not that we must have, but we should have an area of wind that have wind speed around 6 meter per second or higher. Okay, later on we see how much the wind speed in areas, states in Malaysia. All right. So if you have around 6 meter per second or higher, then it more likely potential to apply this wind turbine. Okay, wind energy. So this wind energy can generate from 100 kilowatt to 3.2 megawatt at peak design conditions. So if we if we use the wind turbine at its particular design condition, okay, means that certain wind turbines are designed at different design conditions. Okay, to in order for it to achieve optimum and optimal efficiency performance. Okay, so if we operate the wind turbine at its respective design conditions, it can generate from 100 kilowatt to 3.2 megawatt. Okay, so and then the rotation of speed, okay, the speed of the turbine, the blades, is under 40 rpm. RPM here is the RPM is rotation per minute. Okay, rotation per minute. Okay, normally we write per minute, and then when we want to calculate, we change it into second because second is the SI units. Under 20 RPM for large turbine, but for large turbine, it's 20 rotation per minute. Okay, this is for the general 40. Okay, the disadvantage of this wind turbine, most of them are expensive, and it can produce power only when wind is blowing. Okay, often far from traditional power grids, unsteady power output. So it depends on the wind, the blow or the wind speed. Okay, so if there's no wind, or if the wind speed is not high, not very high, so it is maybe not applicable enough. Okay. Next, wind turbine types and power performance curve. Okay, these are two basic types of wind turbine. So we have horizontal axis and vertical axis. Okay, so you can see the picture here. Okay, this is horizontal and this is the vertical. Okay, I think the most common that we usually see is the first one, this one, right? Horizontal axis. This one, I think most of us have seen this, maybe seen in books or video, etc., or maybe you have seen this live. Okay, me myself, I have seen this one, the first one, a lot. Okay, especially in Europe. But the second one, I think me neither. I have never seen it before. I think real life. I'm not sure. Okay, I think I've never seen it before, but it exists in Switzerland. This one. Okay, the vertical axis turbine. Okay. Okay, so the length of the blades, okay, okay, this is what we call blades. This one is blades. So the horizontal axis normally have three blades. Okay, so the blades, the length of the blades is the biggest factor. So the biggest factor to determine, to evaluate the amount of electricity produced by wind turbine. One of the biggest factor is the length of the blade. So we have to design an optimum. We have to know as a designer, a design engineers, we have to know how long the distance of the blades in order to achieve a certain amount of electricity production. Okay. Small wind turbines that can power a single home may have an electricity generating capacity of 10 kilowatts. Okay, small wind turbines can produce 10 kilowatt. Okay. The largest wind turbine in operation has electricity or generating capacity of up to 10 megawatts. Okay, so we can achieve largest can achieve to 10 megawatts. Okay, so horizontal axis turbine are similar to propeller airplane engines. Okay, so that's why, like I've mentioned just now, if you are from mechanical or aerospace background, we can relate this a lot. Okay, because we use the same concept, the same fundamental. Okay, in for propeller airplane engine, so we use the same concept in for horizontal axis turbines. Okay, so commonly horizontal axis turbines have commonly three blades. Okay, so taller turbines, longer blades, evidently have more generate more electricity. And then the vertical axis turbine just now, it is like 8 beaters we see, right? Like a beater. Okay. Okay, wind power potential. Okay, mechanical energy. Okay, so what does this wind power can do? It can transform into mechanical energy. Okay, to make convert it into mechanical work, and by using a device which is normally a turbine. Okay, the turbine used to convert to transform the energy from the wind speed, from the fleet of they extract the energy from the fleet, which is from the wind, to and transfer it to mechanical work, mechanical energy. Okay, so so this available wind power. Okay, okay, so we have the technical data of wind turbines. For example, so this characteristic, these are the example of types of wind turbine which are available. Okay, from this source. So it has the rated power 20 kilowatt until up to 100 kilowatt. The rotor diameter, the cut or the rate, the wind speed. Okay, so you can see here. Okay. Applications of wind turbine. Okay, so there are three applications of wind turbine. The first one is the land base. We can install, okay, the wind turbine on land. So this is the most the usual one that we see, I think. Okay, okay, so it it range from 100 kilowatts to as large as megawatts, several megawatts. And then we also have offshore wind turbines. Okay, So offshore wind turbines are able to capture powerful ocean winds. Okay, of course, at the ocean we have very very powerful wind speed, so it can produce a lot more power energy. Okay, offshore wind, and then we have also distributed wind. Okay, this is more maybe seldom means seldom used, seldom we can not we don't see it quite often. Okay, distributed wind, when wind turbines of any size are installed on the customer side of the electric meter or installed at or near the place where the energy they produce will be used, they are called distributed wind. Okay, so so this is an example where means that the wind turbine is installed, and install more at the consumer place, means at for example here customer side, and this energy this energy the energy produced will be used by the consumer customer around. Okay, so what we call distributed wind, it's like this distributed electricity, like that. Okay. Okay, this table of wind power density. So okay, so to quantify the characteristic of a wind turbine, we use wind power density, wind efficiency, right? So those are the parameters that we use to characterize the performance of wind turbines. So one of them is wind power density, that or WPD is a quantitative measure of wind energy. Okay. So it is the mean annual power available per square meter of swept area of a turbine, and is calculated for different heights above ground. So for example, at 10 meter, at 30 meter, and at 50 meter, we have those power density, watt per meter square. So this measure depends on the area. Okay. So so at at higher level of altitude, 50 meter, we have of course more wind power density and higher speed, of course. At higher level of altitude, there are the wind speed is higher, and so of course the wind power density is higher. Okay. Wind turbine efficiency. Okay, a wind turbine is typically around 30 to 45% efficient. Okay, not bad, not bad. Rising to 50% efficient at times of peak wind. Okay, so it can be until 50%. Okay, so 50% is already good enough. Okay. Later on, I have example exercise. We see the how do we calculate the wind turbine efficiency. Okay. Advantage of wind power. Okay, so these are some of the advantage of wind power. Okay. One advantage is that it is cost effective. Okay, so for example, the land-based wind turbine just now, it is one of the lowest price energy source available today. Lowest price energy source, it is one of the lowest, not the lowest. It is one of the lowest, lowest cost energy source if they are available today. Okay, for land-based, I should have write that one first. Land-based wind power just now. Okay, that we usually see. It costs about 1 to 2 cents per kilowatt hour. Okay. And then wind create jobs, of course. Okay. Actually, all type source of energy technologies will create jobs for people, right? For citizen. Okay, it is a clean fuel source, of course, because it is a renewable energy. We use the nature, okay, so it doesn't pollute. Wind is a domestic source of energy. Okay. Uh, Domestic depends on the country. Okay. For a country like China, US, just now Germany, so it means that they use their own source of wind, so their own source of energy. Okay, it is sustainable. Okay, since it is a form of solar energy, the nature, it comes from the nature, so it is sustainable. As long as we have this world. Okay, so the energy is the solar, the wind is always there. Okay, wind turbines can be built on existing farms or ranches. Okay, so this will greatly benefits the economy in the rural areas especially. Okay, and challenge of wind power, of course. When there are advantage, there are also a challenge. Okay, so some of them challenge of wind power. Wind power must still complete with conventional compete. Sorry, with conventional generation source on a cost basis. Okay, so even though we have a solution of renewable energy, we still have to compete with the conventional fossil oil, coal in terms of cost, because some people still look at the cost rather than the clean or sustainable criteria factors, right? Because money is everything, right? So they still look at the cost. So the wind still have to compete with that. Good land-based wind sites are often located in remote locations, so we need enough sites area, right? So the location always at the remote kat kampung-kampung kan, jadi far from cities where the electricity is needed, right? Usually people from the urban area in the city needs electricity, they use electricity more compared to the people at the rural in the village. But the sites, the land-based wind sites needed often located in remote locations. So there is a challenge. Okay, wind resource development might not be the most profitable use of the land. Okay, um they also, this wind energy, also wind power, have to compete with the other how to say, the possible size need to be used for other application, other possible function, right? So we have to compete whether we want to, for example, whether we want to install this wind turbine, or we want to build more house using the same land. Okay, so there's always a challenge like that. Okay, turbines might cause noise and aesthetic pollution. Okay, so there's also noise impact. Wind plants can impact local wildlife. Okay, so birds, especially since it's the winds, the turbine will have to rotate to generate power, to create power. So when the blades of the turbine blade rotates, sometimes birds, especially birds, burung, have been killed by flying into spinning turbines. So the birds sometimes accidentally hit the turbine blades. Okay, so it impacts animals, local, negatively. Okay, bats. Okay, those animals that flying, sometimes they accidentally hit the wind turbine, so it's not very good for those animals. Okay, so let's see some data, especially in Malaysia. So I was available to find some of articles, quite recent articles. This one is in 2019 or 2017, I don't remember. But this article, this paper, here, this is the link. Okay, if you want to search for the paper. So the paper entitled "Wind Energy Generation Assessment at Specific Sites in a Peninsula in Malaysia Based on Reliability on this." Okay, so we see this map of Malaysia. Okay, even though it's quite small, but it's okay. So at least you know the colors. Means that the colors are the darker, the more darker, the red one or the orange one. Those parts has wind speed higher than the yellow or light orange one. Okay, so if we look at the Semenanjung Malaysia, Peninsula Malaysia, okay, the map of Peninsula Malaysia here. Okay, so basically Selangor, Lembah Kelang, Klang Valley, we only yellow means that the lowest wind speed it's in Peninsular Malaysia is in Selangor. So basically it's not very useful to apply, maybe to apply wind turbine, wind energy in Selangor or in Klang Valley, because we don't have enough wind speed in Klang Valley. Otherwise, the most in Peninsular Malaysia, the highest wind speed available is around here, Pahang, Johor. But still small, around 2.4 to 2.7, which is lower than how much just now? 6 meter per second. That's been stated in the beginning, right? At least we need 6 meter per second of wind speed or higher in order for the wind turbine or wind energy to be applied, whether it is worth it or not, right? To be applied. So the highest that we have is around 2.5 meter per second in Peninsular Malaysia. Whereas in quite the same in Sabah, at Sabah, this is the map of Sabah. We don't have Sarawak yet. This article that didn't put map of Sarawak. In Sabah, the wind speed, the highest wind speed orang Kudat, okay, 2.5 meter per second. Or here, I'm not sure. Is this Kota Kinabalu? Lupa, I'm not sure. Yeah, around here. Okay. So this paper it studies three different location in Mersing, Kuala Terengganu, and Kudat. Okay, so this is Kudat, Mersing here. So Mersing number one, Kuala Terengganu number two, and this is Kudat. So they compare. They compare between these three location, because as you can see from the map here, these three location have at least the most powerful wind speed, even though it's not very high, still around 2 to 2.5 meter per second, but it's the highest that the Malaysia has. So at those latitude and longitude. But remember just now I've mentioned that this wind energy, wind power also depends on the altitude level. Okay, so if we have, if we locate the plant, if we install the wind turbine at a higher altitude, for example, Mersing here at 43.6 meter at a higher level, so we might produce higher wind power. Okay, it depends on the altitude of the location as well, not just the wind speed. Okay, so these are again the data found by the same paper just now, this paper. Okay, so for example here, it shows the wind speed at I think at lowest altitude, and then 60 millimeter and 100 meter. So of course at higher altitude the wind speed is higher, and throughout the year, so in Malaysia we have our wind speed is higher at the beginning of the year and at the end, December, January, February. So we have more high wind speed in at Mersing. Okay, this table, this result is about Mersing. So in Mersing, at December, January, February, we have higher wind speed. Okay, so we even reach 6 meter per second, the minimum wind speed advisable to have. before we apply the wind turbine, right? So we can even reach in January at Mersing in January with at the altitude of 100 meter, we can reach wind speed above 6. Okay. Wind power and energy density characteristic at heights of 43.6 meter and 100 meter in Mersey. Okay, so at this different height, 43.6 and 100 meter, we can see the wind power density just now. Okay, achieve in Mersey. So conclusion from this paper, they make conclusion that the wind resource at specific sites in Malaysia are more suitable for small scale standalone energy conversion systems and could also be hybrid energy system. Okay, so the conclusion that they made, there are two suggestion. One, it says that by looking at the wind resource, wind speed, altitude, etc., in Malaysia at certain sites location in Malaysia, they make a suggestion that by looking at those parameter, that small scale standalone energy conversion is more suitable to be applied in Malaysia. Small scale means not too big like the wind turbine, wind power. Okay, small scale energy technology. Or if you want still, if we still want to install for example large scale technology like wind power here, we could use it as a hybrid energy system. Hybrid means that for example, wind plus solar or wind plus hydropower. So we have at least two source of energy. Then it will be maybe worth it to install wind turbine. Okay, at those sites in Malaysia. Okay, another paper that I found here from 2019. Here, this one. This is also the link if you want to look at it. Potential evaluation of wind energy in Kuala Terengganu. Okay, again in Terengganu, Pantai Timur, East Coast, Malaysia through Renewable distribution method. So it is the name of the method. It's okay if you don't know about that. Okay, so this is the they have done statistic analysis, okay, of the data, and they make a conclusion. Okay, so we just look at the conclusion. Okay, but before we look at the conclusion, look at this. The figure 3, graph of monthly potential wind power in 2017. We look at again December, January, February, especially in December. Okay, the wind power density can exceed to 106 watt per meter square. Okay, so very very high. So it has a potential. It's just that it is only can be used at very specific these 3 months especially. So we see that wind energy, wind turbine, it is not really applicable throughout the year, the 12 months. Only applicable at least 3 months. So we can see here why the researchers suggest that we use if we want to use wind power, wind energy, we use it as a hybrid energy. Means that alongside other source of energy. Okay, because for the other 9 months from March to November, we might don't have enough wind energy produced if you use only wind turbine. Okay, so the conclusion, overall the potential of wind power in Kuala Terengganu is not too large. Okay, the annual average for year 2017 is 2.5 meter per second, the wind speed. There are several factors, okay, because due to monsoon wind location, okay, wind power is high during the northeast wind monsoon season, okay, the December, January, February. Energy from the wind can be produced better for the exposed area with the northeast monsoon wind. Meanwhile, the power of electricity may be inadequate during the southwest monsoon season, okay, it is not enough. It is not sufficient during March to November. But if photovoltaic panels are used for hybrid electric power generation, again, means that it suggests to install another types of source of energy, which is photovoltaic solar panel. Used for hybrid electric power generation, it is possible to obtain good economic benefit. So if you use wind energy alongside another types of renewable energy, maybe it can benefit. Okay. Okay. So so I have two example of exercise here, but maybe I'm just going to explain exercise one. Okay, I already give answers here. Okay, so you can try out by yourself, but maybe I show a bit on exercise one. Okay, so we look at the exercise one. I hope that you try to do it by yourself also. Yeah. Okay, first one. A wind turbine with a 50-meter diameter rotor is rotating at 25 rotation per minute under steady winds and an average velocity of 10 meter per second. Okay, the electrical power output from the turbine is 375 kilowatt. The combined efficiency of the, gearbox generator is 90%, taking the density of air to be 1.2 kilogram per meter cube. Determine first the wind turbine efficiency. Okay. So how are you going to determine the wind turbine efficiency? First, okay, we have information on the wind power, 375 kilowatt, and we know the efficiency of the generator. Okay, so we can remember the definition of efficiency. The definition of efficiency efficiency equals to the power produced over the power intake, power at the inlet. Okay, so efficiency wind turbine, this wind from efficiency of electrical efficiency first from the generator, right? Okay, so electrical over the shaft. The shaft is the input power. Okay, so we can calculate this one. Okay, so we calculate this one. Shaft is N, generator, which is 90%, 0.9 times 8. Not times, sorry. Uh, let's keep. So shaft. So electrical power just now over the efficiency. Okay, so we have this shaft power. Okay, but not the answer yet. Okay, we have shaft power, and then we have to know, we have to calculate the area of the blade. Okay, the area of the blade can be calculated here, A pi d, pi d square over 4. This one you know. Okay, pi d square over 4. So the diameter is given here 50 meter. Okay, 50 meters. So you have the answer for area. Okay, and then we calculate the wind turbine efficiency. So the definition of wind turbine efficiency is the shaft power just now over, okay, over the 1/2 rho A V, the available power. Okay, I will explain where does this come from. Okay, so first, okay, how do we get this one, the available power? This is the available available power. Okay, available power. Okay, eksperimen ini. Okay, pada balik. Okay. Available power. Okay. Remember, wind energy, it converts the wind turbine, it converts kinetic energy of the fluid, to the power, mechanical power or electrical power, right? So, we use the definition of kinetic energy. Okay. We know that kinetic energy is 1 over 2 mv square, right? This is v square over 2 is the kinetic energy equation. Okay, so but this one is in terms of power, so we multiply with mass flow rate. Okay, mass flow rate, m dot. Okay, this is comes from kinetic energy. Why kinetic energy? Because wind turbine, it transform the kinetic energy of the fluid, the wind, to mechanical power, electrical power. Okay, so that's why the first law of thermodynamics is important. Okay, so kinetic energy. Um, okay, so and then this mass flow rate can also be written conservation of mass rho as rho AV, right? Rho AV. So when we replace this one inside here, so that's why we have this 1 over 2 rho AV power of 3, okay, as the available power. Okay, so back to our exercise. Okay, back to our exercise. So we can calculate the turbine efficiency. So we have the answer 35.4%. So you can try. Okay. Next, B, the tip speed of the blade. Okay, in kilometer per hour, the tip speed of the blade. Okay, tip speed of the blade. Okay. We have the information of diameter. Okay, the diameter of the blade is 50 meter, and we know that the blade is rotating at 25 rotation per minute. Okay, so how are we going to calculate the tip speed of the blade? Speed of the blade at the tip. Okay, if you remember, the circumference lilitan lilitan satu bulatan tu, it's the formula is pi d. Okay, perimeter, the perimeter lilitan, circumference, pi d, right? Okay, pi d, the pi d lilitan tu satu lilitan, one rotation or one revolution. Okay, but here it's stated that the turbine rotates at 25 rotation per minute. 25 rotation, dalam satu minit ada 25 rotation. Tapi satu rotation ialah pi d. Okay, so in order to calculate the VT, we multiply, okay, we multiply the pi d, okay, we multiply the pi d with 25 rotation. Okay, so I note it as 35 rpm. Okay, and then you have to change that RPM is in minutes, so you have to change into second. Okay, or hour into hour, because you use kilometer per hour. So just change the unit. Okay, this one is in meter, change to a kilometer, and this one is in rotation per minute, change it into per hour. Okay, and then you will get the answer 236 kilometer per hour. Okay. Last one, number 3, C. The air velocity at the turbine exit if the turbine operated ideally at the best limit. So what is best limit? Best limit is the maximum possible efficiency of any wind turbine, which is equals to 0.5926. Okay, so I'll give the formula, don't worry. Okay. Okay, this one also easy. So you calculate, means that the ideal velocity. Okay, Bat's limit is the ideal velocity, the maximum possible velocity. So it is written as this one, V1 over N, wind turbine maximum, the ideal one. Okay. So just now, V is the velocity, which is 10 meter per second given here. And 1 minus 0.5926. Okay, this Bat's limit. Okay, square root. Okay, so you have the answer is 6.38 meter per second. Okay, yeah, I hope that you understand. Okay. Okay, so you can do that and try to do also this exercise too. So the answers are given here. Try to calculate the electricity produced, the power, okay, etc. Okay, so that's all for this week class chapter. So inshallah we will discuss more again about this wind energy during your presentation. Okay, in 2 is to come. Okay, inshallah. Okay, that's all from me. Assalamualaikum. Thank you very much.